Hello everyone. Today I'll be talking about how and why humans have developed different skin tones. In my opinion, skin tone variation is one of the most fascinating and important adaptations of our species. First, I'd like to talk about how our bodies develop pigmentation. Melanin is a dark pigment produced by the melanocytes in the epidermis of the skin, the matrix of the hair, the irises of the eyes, and elsewhere in the body. Within the melanocytes is the melanosome, which transports melanin to the skin and the roots of the hair. There are two main types of melanin relating to skin, hair, and eye color called eumelanin and phosphomelananin. While all of us have both eumelanin and phosphomelananin in our bodies, expression of each type varies greatly. Those with higher expressions of eumelanin have darker skin and or hair, as it is a brown to black colored particle. Those with higher expressions of phosphomelananin will have lighter skin and blonde or red hair, as phosphomelananin is a pink to red colored particle. And let me just move myself out of the way really quick so you can get a better idea of what that looks like. Okay. So as humans have migrated to different regions of the world and explored different latitudes, we've encountered and adapted to new environmental conditions. At higher latitudes, there is a smaller angle of solar radiation, meaning energy is less concentrated and spread over a larger surface area, causing cooler temperatures, according to climate science investigations. Closer to the equator, radiation is more direct and concentrated over a smaller area, causing warmer temperatures. So essentially, where you live has a great impact on your skin tone. While all skin tones are at risk for skin cancer, individuals with darker skin tones are more protected by the melanin, specifically eumelanin, in their bodies from developing it. However, those of us with greater expressions of phosphomelananin than eumelanin have a harder time protecting sensitive skin tissues from UV radiation. This can lead to abnormal cell development and malignancies, as discussed in our textbook's Adaptation, Evolutionary Basis for Skin Tone Variation, a section beginning on page 531. In addition to protection from skin cancer, increased melanin levels also protect individuals from sunstroke and sunburn. Severe sunburns affect the eccrine glands, which are vital to sweating, which is the body's best means of controlling body temperature and maintaining homeostasis. And while protection from skin cancer and sunburn and sunstroke is a great benefit of having increased levels of melanin, it's important to note that it's most likely not the primary factor in the evolutionary selection of darker skin in equatorial regions prone to higher UV radiation. Skin cancer also primarily occurs in the post-productive years, meaning it's not likely to be genetically inherited. It turns out that increased melanin in regions with high UV radiation positively correlates with fertility. Increased melanin levels prevent folic acid destruction due to UV radiation. According to the Mayo Clinic, folic acid, which is also called folate or vitamin B9, is crucial to red blood cell formation, especially for pregnant women, to avoid birth defects in the brain and spine of the fetus. A lack of folate may result in spina bifida and severely reduces the baby's chance of survival. In men, folate destruction can lead to impaired spermatogenesis, the production of sperm. For both men and women in regions with high levels of UV exposure, folic acid levels are very important, and eumelanin plays a pretty important role. So if there are so many benefits to having increased melanin levels and therefore darker skin, why have humans developed lighter skin? One hypothesis is that lighter skin is related to vitamin D synthesis. UVB radiation causes a chemical reaction in the skin's epidermis, leading to the creation of vitamin D3. Before it's used by the body, it travels to the liver and kidneys, where it's ultimately converted into calcitriol, a regulator in cellular replication. Our bodies need vitamin D to absorb nutrients such as calcium and phosphorus, which are vital to proper bone growth and maintenance. Vitamin D deficiencies in children during the growth phase can cause rickets, inadequately calcified, softer, and more flexible bones. Those with rickets may develop bowing femora, as shown in the photo here. Adults with vitamin D deficiencies may develop osteomalacia, which is also softening of the bones, but they experience fractures more commonly than those without a deficiency. In conclusion, our skin tone is dictated by the levels of melanin in our bodies. Melanin is created within the melanocytes and transported to the skin and hair by the melanosomes. Eumelanin is a brown to black particle, while phosphomelananin is pink to red. Expressions of both eumelanin and phosphomelananin make up your skin and hair color. Darker skin tones with higher levels of melanin are more protected from sunburn, sunstroke, and skin cancers in equatorial regions, and are more protected from folic acid destruction. Lighter skin tones may aid in vitamin D synthesis, which prevents poorly calcified bones in children, such as rickets and osteomalacia in adults. All in all, our skin tones are crucial to fertility, bone growth, and are best adapted to our environments. Thank you so much for watching, and have a great day.